Okay, we're going to talk about 4 problems now dealing with exponents and logarithms. I've boiled these kinds of problems down into 4 basic skills, or 4 basic things that we can do with these problems. The 4 skills are, the first skill is using equal bases using the property of equal exponents. We're doing equal bases of logarithms using those with equal logarithms. We'll talk about that. So equal bases equal exponents, equal bases equal logarithms, the method to log both sides, and the method to exponentiate both sides. Let's take a look at the first problem. Okay, the first problem is equal bases equal exponents. Here we go. So what I have here is I have 4 to the x equals 1/2 to the x minus 3. And you notice that 4 is not the same as 1/2. But you notice also that 4 and 1/2 are similar. So what I'm going to do here is I'm going to use the fact that 4 and 1/2 have some kind of relationship. I can write 4 as 2 squared, and I can write 1/2 as 2 to the negative 1. Okay, so I have 2 to the 2 to the x, and I have 2 to the negative 1 to the x minus 3. Now I'm going to use the fact that if I have something with an exponent raised to another exponent, that's 2 to the 2x equals, I have 2 to the exponent, so this can be negative 1 times x minus 3, so I'm going to do negative x plus 3. What I've done here is I've written it as 2 to a power equals 2 to a power. When the bases are equal, and that's all I have is a base to a power equals the same base to a power, I can use the fact that these exponents must also be equal. 2 to the x, so 2x equals negative x plus 3. That's it. So now we've got a simple equation. I can collect the x's on one side, so I add x to both sides. I get 3x equals 3, x equals 1. Let's check and see if that works. Plug it back in. 4 to the 1, does that equal 1/2 to the 1 minus 3? Okay, well, 4 equals 1/2 to the negative 2. Yeah, that's going to be 2 to the 2, which is 4. Okay, so the concept here is rewrite the left-hand side and the right-hand side as exponents of the same base, and then use the fact that if the bases are the same, the exponents must be the same. Very nice. Let's go on to the next part. Now here's a similar idea. Equal bases equal logarithms. And here's the problem we're going to look at. Log base 5 of 4x minus 7 equals log base 5 of x plus 5. Now, same idea here. We're going to use the same property, and this problem is actually a little easier. Log base 5 of 4x minus 7, log base 5 of x plus 5. If I have logs that are the same base and they're set equal to each other, then the stuff inside must also be equal. This is 4x minus 7 equals x plus 5. Okay, so again, I can go ahead and solve. Subtract x from both sides, and we're going to get 3x. Add 7 to both sides, and we're going to get 12. So x equals 4. Let's double check and make sure that's true. So log base 5 of 4 times 4 minus 7. So 16 minus 7 is 9. Log base 5 of 4 plus 5, that's 9 as well, so 9, yep, log base 5 of 9 equals log base 5 of 9. Okay, so method 2 was when we have the same base logarithm and the logarithms are set equal to each other, the argument, the thing inside the logarithm, must also be equal. Okay, let's take a look at the next version. So equal bases equal logarithms. The next one is the method to log both sides. Now I'm going to show you 2 methods here. Okay, I said I'm going to show you 2 methods. Method 1, to log both sides. Now, the way I'm going to start for the first method is I'm going to look and say I have a 4 here as a base. So I'm going to choose to log both sides, and I'm going to use log base 4. So I'm going to log the left-hand side, and what I do to the left-hand side I must do to the right-hand side. Okay? Now, we have this here that log base 4 of 4 to the x, one of our identities says that's just equal to x. So x equals log base 4 of 11. Now, I'd like to point out here that you could have jumped directly from here to rewriting this as log base 4 of 11 equals x. Okay? But we're going to do it a slightly different way in a moment. Okay? That means, using the change of base formula, that log base 10 of 11 divided by log base 10 of 4 is what I'm after. So let's go ahead and do that using Wabbit here. So log base 10 of 11 divided by log base 10 of 4 is 1.729. So if I raise 4 to that power, I'm going to get 11. Let's check it. 4 to that power, yep, I get 11. Okay? Now I'm going to show the other way of doing this, which I find personally a little easier. So I start again with 4 to the x equals 11, and I log both sides. But instead of choosing to use log base 4, I'm going to use log base 10. Why? Because I like log base 10. It's got a button in the calculator. So here's what I'm doing. I'll take log base 10 of both sides. Now, I'll also say that this would work equally well using log base e, ln, because ln is also a button in the calculator. Okay, so I have log base 10 of 4 to the x equals log base 10 of 11. Now, what I'm going to do here is I'm going to use another property of logarithms. Log of 4 to the x is the same as x log of 4 equals log of 11. But now take a look at this. X times log of 4 equals log of 11. I can divide both sides by log of 4. And I'm left with x equals log of 11 divided by log of 4. The advantage to this method is you don't have to take any time thinking about which log to use. Always use log base 10, or always use log base e, the natural log. So you don't have to do that bit of thinking. The other thing I like about this method is that you don't have to use the change of base formula as we did from here to here. Instead, I automatically get that ratio at the end without having to use another formula. Okay, so that's the way I like to do it, is to take log base 10 of both sides. Okay, let's look at the last example. So this was the example where we log both sides. The last example is to exponentiate both sides. Okay, now before we get into this problem here, I should mention, when are you going to decide to log both sides versus exponentiate both sides? Okay, we're going to choose to log both sides when we see x in an exponent. If x is in an exponent, you need to take a log at some point in the problem. If x is inside a log, like we have here, we need to take an exponent at some point to get it out. So if x is stuck inside the exponent, you must use a log. And if x is stuck inside the log, you must use an exponent. That's the rule. So here's a situation where x is stuck inside the log. I need to use an exponent. Okay, let's go ahead and do this. Okay, x is stuck inside a log. So here's a situation where I need to think about what base I have for this to really work well. I have log base 4. Okay, because I have log base 4, I'm going to exponentiate both sides using 4 as my base. So what I'm going to do is I'm going to take 4 to this equals 4 to this. Now I chose 4 strategically because 4 to the log base 4 of something is just that something. This side here is simply equal to 5x minus 1. And the right hand side is equal to 4 cubed. Okay? So I end up with 5x minus 1 equals 64. So 5x equals 65. So x equals 13. So x is 13. So what we did here was when I exponentiate both sides, I choose the base of that exponent to be the same as the base of the logarithm. If I do that, I will automatically get this, which is what I'm trying to do, get that out of the log, and then I can just use my algebra skills like you did from here on. From here on, it's just simple algebra. Okay? So let's go back and summarize. Back to the beginning. There were 4 skills. If we see an equation where we have exponential equation with exponents on both sides, if I can write the left-hand side and the right-hand side as exponents with the same base, then I can take equal exponents. If on the left and the right I have logarithms, and the base of the log on both sides are the same, and all we have is log of the first equal to log of the second, I can take the stuff inside and make those equal to each other. The thing I like here is whenever I see an equation with x in the exponent, a way to get that out is to log both sides. You can use any base you like. I like log base 10 and the natural log. The other thing is that whenever I have x inside of a log, I can choose to exponentiate both sides. The base that I'm going to choose will be the same base as that of the logarithm. Okay, that's it, guys. Thank you so much.